Hello, welcome to our channel. In this video, we will talk about functions. We will look at the conditions when a relation is a function, and we will also talk about the notations of functions. So here is the basic definition of a function. A function is a relation from one set to another such that each element from the first set maps to exactly one element in the second set. So if you have two sets A and B, you have a bunch of elements here and some elements here. So this particular element can map to only one element for this relation to be a function. Instead of that, if you have something like this particular element being mapped to two elements here, this is not going to be a function. This is still a relation, but not a function. This is a function, this is not a function. So let's look at some examples. In the following relation of function, we have a relation square of x is y. So here these are x values and these are y values. So if you look at the correspondence here, we need to make sure that each element from the first set maps to exactly one element in the second set. So 0 is being mapped to just one element 0, 1 is being mapped to just one element 1, -1 is being mapped to just one element 1, and the same thing with 2 and -2, they are being mapped to just one element 4. So there is no x value that maps to two elements. There is no x value that maps to two y values. So this is a function. Now let's look at this relation. So here we have some x values that map to multiple y values. So for example, Mary is being mapped to two y values, Michael and John, which is a problem. So this is not a function. Because this particular x value, Mary, is being mapped to two y values, Michael and John. And the same thing with Zane also. Zane is being mapped to two y values, Nancy and Peter. So this is not a function. Here are some more examples. We want to determine if these are functions, and we want to determine domain and range in each case. So if you look at the first one, we have the relation given this way, 2 being mapped to 6, -2 being mapped to 6, 3 being mapped to 9, 4 being mapped to 12. So we ask if each x value is being mapped to only one y value. So 2 is being mapped to 6 only. There is no other 2 over here as x value. -2 is being mapped to 6 only, 3 is being mapped to 9 only, and 4 is being mapped to 12 only. So we see each x value is mapped to only one y value. That means, therefore, this is a function. And we can determine the domain and range. So domain is the set of all the x values. So 2, -2, 3, and 4. This is the domain. And range is the set of all the y values. So 6. And 6 again here, so we don't have to write that twice. 9 and 12. This is the range. Now let's look at the next example. So again, we ask if each x value is being mapped to just one y value. So if you look at 2, this 2 is being mapped to 6. But again, 2 is being mapped to 9. So 2 is being mapped to two y values, 6 and 9. So this is a problem. So this is not a function. So this the second relation is not a function because 2 is being mapped to two values, 6 and 9. We can still write down the domain and range of this relation. So the domain is all x values, 2, 3, and 4. And the range is all y values, 6, 9, and 12. Now let's look at the next example. Candidate Y is elected in presidential election in the year X. So here we have year, and here we have elected candidate. So these are the two sets we are talking about. So for any particular year, we have just one candidate being elected. So one X value is being mapped to only one Y value. That means this is a function. There is no X value, there is no year when we have two Y values, when we have two presidents being elected. So that makes this relation a function. We can describe what the domain is and what the range is. So the domain is all the years when we have election. So this is simply the set of election years. And the range will be the set of presidents, basically. Right. So now let's look at the last example on this page. We have candidate Y ran in the presidential election in the year X. So in this case, again, we have the first set, the X values to be year. And here we have the running candidates. Now, in this case, for any year, for example, 2020, year 2020, we had a number of candidates running in the election. So maybe 3 or 4, we had a lot of candidates running in the election. So this is not a function because one X value is being mapped to a number of Y values. So this relation is not a function. Again, we can describe the domain and range here. The domain is simply the set of election years. And the range is all the candidates that ran in all the elections. Set of presidential candidates. So that would be the range. So basically in all of these examples, we need to make sure one X value is being mapped to only one Y value for the relation to be a function. Now let's talk about notation of a function. So we generally denote a function by lowercase letters like f. So this is the most commonly used notation for a function, this lowercase f. When a maps to b by function f, we write f of a equals b. So that means function of a equals b. So if you have a being mapped to b by f, then f of a is b. Another way to look at it is you can think of f as some machine. So your input is A and your output would be f of A, which is some other number B. Right, so here are some examples. Just find f of -1. So -1 is being mapped to 1. That means f of -1 is simply 1, because -1, but the output for -1 is 1. Next, it says f of 2. F of 2 is being mapped to 4. So f of 2 is 4. Next, it says g of 2008. Now the function g is over here. So g of 2008 would be the person who was elected in that election year. So 2008 is being mapped to Obama. So g of 2008 is Obama. And the last example here, g of 2021. So there is no 2021 in the domain. We didn't have any election in 2021. That means this g of 2021 is undefined. So we can't, this function g cannot take input 2021. So this function g cannot have x value 2021 because it is not in the domain. And here are more examples, particularly about using the notation for functions. So for the first one, the function h is given like this: 2, 6, -2, 6, 3, 9, 4, 12, which says find h of 3. So we want to find the output of the function when input is 3. Looking at these ordered pairs, we want to look at the one where x value is 3. So we have 3 over here. This is x, and this would be h of x. So h of 3 would be 9. Next, we want to find k of 3 for this function. So again, k of 3 over here is 9, because 3 is being mapped to 9 again. Next, here we want to find p of 2008. So the function p maps year to the president elected. That means p of 2008 would be Obama, because he was the one who was elected in 2008. The next function c, maps a real number to its cube. So c of 3 would map 3 to its cube, so 3 cubed, or 27. So c of 3 is 27. Q maps a real number to its square. So q of 3 would be 3 square. So if you input 3, then your output would be 3 square, which is 9. Hope it was helpful. Thank you for watching. Please subscribe to our channel if you haven't already. Thank you.